Hi, this is Mr. Beckstrom, and today we're going to look at a problem from section 4.3. This is on complex zeros and the fundamental theorem of algebra. And here we have a third degree polynomial, and it says find the complex zeros of the following polynomial function and write it in factored form. So remember that imaginary roots come in conjugate pairs. That means we'll always have an even number of them. So we'll have either 0 or 2 or 4. In this case, since it's a third degree polynomial, at most we can only have 3 total zeros. And that means that I'm either looking for 0 imaginary solutions or 2 imaginary solutions. So I'm going to go ahead and try to look for a rational zero, a real rational zero first using the rational zero theorem. And we've done this before, so in order to do that, I'm going to look at all the factors of 87. This is both positive and negative. So I'm going to have plus or minus 1. I also have plus or minus 3 because 3 is a factor. I also have plus and minus 29. Because 29 is a factor. And finally, I'm going to have plus or minus 81. Excuse me, 87. All right. Now, this is going to be my factors of my constant. And remember, I'm going to put those all over the factors of my coefficient of my leading term, which is going to be 1. So it's not going to change any of these. But if this was something other than 1, then I would need to divide each one of those by each one of the factors of the leading coefficient there. So here's the possible rational real zeros that I'm going to have in this function. And I'm going to use my calculator in order to test those. So what I'm going to do is go to my calculator. I've already put it in my y equals, so I'm going to put the function in just like this. And then remember, that easy way to do it is we go to second Windows, which is the table set, make sure our independent is on ask, our dependent is on auto, and then I'm going to do second graph, which is my table. And then for any x I put in here, it's going to evaluate it and put the y. And if I get a 0, then that means that that value for x is one of my zeros of the function. So I'm going to try 1 and negative 1 first. 1, no. Negative 1, no. Now I'm going to try 3 and negative 3. Remember, I'm looking wherever I get a 0 over here. So 3, oh, there we go. And negative 3. And let me go ahead and just try all of them just to make sure I don't have any more. So 29, nope. Negative 29, nope. 87, no. And negative 87, no as well. So the only ones that I'm looking at this point is 3. So remember synthetic division. I'm going to go ahead and put the 3 here on the outside. And then I'm going to put the coefficients from my third degree polynomial right here. So 1, negative 13, 59, and negative 87. And the idea here is that when we pull this 3 out, we should get a second degree polynomial that we can use. So bring down the 1. 1 times 3 is 3. Add those together, I get negative 10. Negative 10 times 3 is negative 30. Bring that down, I'm going to get 29. And 3 times 29 is 87. And negative 87 plus 87 is 0. So sure enough, 3 was a factor. That means if I put it in the factored form, which is x minus 3, I'm going to be left with this quadratic, which is 1x squared, or just x squared, minus 10x plus 29. All right. And from here, I can pretty easily see that this is not factorable. And in fact, we did this quadratic in another video. So I kind of already know what the solutions are, but let's go ahead and work that one out. So they want us to put it in factored form there, so we need to find the zeros of this quadratic as well. And then we'll put those factors along with this factor. So working this one here, I'm going to have negative b, which is going to be a negative of a negative 10 plus or minus the square root of b squared, negative 10 squared, minus 4 times a, that's the coefficient there, times c, all over 2a, or 2 times 1. All right, so now what I'm doing here is I'm going to go ahead and work this out. So this is 10 plus or minus. This is going to be 100 minus what's 4 times 29? That's going to be 116. So this is going to be 100 minus 116 is negative 16 all over 2. And this is 10. Remember, this is an imaginary solution, so we can rewrite this as 16 times the square root. The square root of 16 times the square root of negative 1, and the square root of negative 1 is I. So this is going to end up being 4i all over 2. And then this finally gives us 2 solutions. If I divide both of these numbers here by 2, I'm going to get 5 plus 2i. And I'm also going to get 5 minus 2i. So these are solutions. And then in order to write this entire thing in factored form, we're going to start with the x minus 3, the x minus the first 0, and then x minus the second 0, this 0, and I'm going to put this in parentheses to remember to distribute, 2i. And then finally, we have x minus that third 0, which is 5 minus 2i. Oh, a little cleaner. Then finally, if we want to distribute those minus signs, this is going to be x minus 3 times x minus 5 minus 2i times x minus 5 plus 2i. And that should be our final answer. And if you have any questions, let me know, and I hope you have a great rest of your week. Thanks.